spannendes Thema, weil es ja viele alte Geräte gibt in Produktionsumgebungen, in kritischer Infrastruktur, überall. Und die müssen natürlich entsprechend geschützt werden, ohne dass man sie anfasst, ohne dass man etwas verändert. Und da freue ich mich schon auf den Ross und auf seinen Vortrag. So, Ross, it's your turn. So.
Thank you, Richard. Good afternoon, people. Please forgive me should my voice break during the presentation today, as I have a rather nasty flu bug at the moment. So I'm the EMEA Sales Director for Garland Technology. We're an American manufacturer of network visibility products for both IT and OT environments. My own personal background is in both networking and security, having been originally an engineer, then I moved into consultancy, and more recent times I've been in the sales side of things. So industrial control systems are used in almost all infrastructures that are handling physical processes. Previously, many attacks on OT environments have targeted older devices running unpatched software, which pretty much indicates that these OT networks were being targeted by IT-based legacy attacks that are no longer effective in IT networks. However, in more recent times, there's been a significant rise in purpose-built OT attacks designed specifically to target SCADA and ICS environments. Attacks specifically designed for OT systems are often specifically targeted at safety systems, for instance. For those OT organizations responsible for critical infrastructures, any sort of compromise needs to be taken extremely seriously, particularly when there is a safety concern. The NIST regulations are driving the adoption of more advanced security technologies, processes, and procedures. And in light of the increasing frequency of incidents and newly discovered vulnerabilities for ICS, all asset owners need to address potential vulnerabilities urgently. This applies to sorry, pardon me. This applies to infrastructures that are directly connected to the internet, as well as those that can be compromised by cyber attacks indirectly. While IT systems use standardized TCP/IP, OT environments use a wide variety of protocols, many of which are specific to various functions or industries and geographies. This in itself creates challenges, as those responsible for security have to create and manage multiple security systems to secure their environment. As with legacy IT-based malware attacks, these structural problems are exacerbated by poor security hygiene practices within many OT environments, often as a result of digital transformation efforts. In this next slide, we're going to look at the top 5 OT security threats. So really the top 5 threats, what we're seeing is malware infiltration via external hardware, like removable USB drives and removable medium, etc. This is a serious threat to OT environments. Human error. So in OT environments, employees and external personnel, such as maintenance or contract workers, are errors by them can be a potential threat to that OT environment. DDoS attacks and IoT botnets. Firms increasingly have different kinds of IoT technologies connected to their network. The actual security of this IoT environment is a primary concern, and many exploits we're seeing through these type of devices in OT environments. And then, of course, we have malware infection through the internet or intranet. For example, the Triton virus in 2018 targeted security or SIS controllers. This attack was especially concerning because in many aspects, it was the first true cyber physical attack on OT systems. An attack could potentially be much worse, not only destroying machinery, but threatening lives. You have to remember the Colonial Pipeline attack. And then we're starting to see also attacks through compromised cloud components. In this survey conducted by Make UK, it looked at evaluate lots of a cross-section of industries, particularly manufacturing. So these results are from the manufacturing aspect of the top OT security concerns that were identified by manufacturers. So up front, the fact that they were having to maintain legacy IT systems with the vulnerabilities that existed within those legacy IT systems. There's an absolute shortage of cybersecurity skills within business today, particularly in these OT environments. Some other interesting points here. They identified that no single tool or sensor can provide visibility into all threats. So in particular, there's often a requirement for more than one security device. The increased attack service was a concern, visibility, that you need to actually look into more locations, this IoT environment, and a generic lack of visibility of OT technology on the manufacturing floor. So one of the underlying trends here is that there's a need for visibility of the traffic on the network to enable security. Now, it's also important to also realize that, or accept that there is no panacea, there is no sole security mechanism that you can use to prevent all attacks. You have to accept that at some point Earth system will be breached. So you make that assumption, and then the importance is actually identifying that you have been breached and then having the processes in place to actually resolve that problem and be able to identify when, how, why it actually occurred, and actually be able to resolve the problem. And again, security and visibility is actually key to actually be able to provide that. So the things that network visibility actually provides, or are the basis for, is asset inventory. So in terms of the NIST regulations, the base level of a NIST regulation is to actually provide a level of asset inventory to be able to identify all the devices connected on a network and their patch levels and any vulnerabilities that are resulting from those patch levels. So asset inventory requires excellent visibility into the network. You need to be able to validate that the architecture that you've designed is secure. to the best of your ability. You need to be able to monitor the behavior of the network, so identify if a malicious actor has penetrated the network, to be able to notice that and actually warn an alarm and resolve that problem. You also need network visibility for capacity planning, for making design changes. And of course, as I've said earlier, the NIST regulations require a level of security that you need to adhere to. And again, network visibility is key to providing that. But there are a number of challenges in providing network visibility, particularly in an OT environment. The challenges are very different to those in IT. Firstly, people are fearful of disruption of the OT network. They're concerned about change. These networks have been running up with a significant uptime for a number of years. They do not want to disrupt that. You often find, or we certainly often find, that the documentation, including things like network diagrams, are not very detailed. There've been changes made and ad hoc updates made, and those changes haven't been the actual documentation hasn't been updated. And we find that common. We find it common is no one knows the length of a fiber run or the type of fiber that's being used. Then there's, of course, this older generation legacy hardware, often which has never been touched, never been patched. We then have the regulators that are imposing this regulatory compliance. So we need to think that. And last but not least, of course, there are budget constraints everyone's working within a particular fiscal budget. So when it comes to network visibility, there's two options. You can use a mirror or span port from a switch, and that will provide access to all the packets in and out of that switch for monitoring purposes. It's software configurable, so you can, and the other key advantage of using a span port, other than being able to see all the traffic on all the ports, is that potentially it costs nothing to actually use that span port on the switch because it's already physically present. The alternative mechanism is to use network taps. So a network tap, you connect between your switches and your PLCs, or your HMIs and your PLCs, or switch to switch. So you connect these on the network link. They're completely non-disruptive and invisible on the network, so you cannot address them. They guarantee on providing a full 100% duplex copy of the network traffic. You can also have a network tap that can provide a single copy, or it can provide multiple copies to different tools, or it can consolidate the traffic. So it can aggregate traffic together. So east-west, west-east traffic is aggregated together and delivered out of a single interface, as is shown in this diagram here. So if you're going to use span, there's some considerations that people need to remember. Span is not always available. I've already mentioned that these environments are often using legacy equipment. Well, some of this legacy equipment may not even support span. So there could be a lot of non-managed switches which have no span port capability. There could be managed switches, but again, have no span port capability. You could also find that there are no available ports on the switches to use span. The other thing is to consider is, well, what media is the switch? What media do you need to take the traffic out of the switch? Maybe it's the wrong media. The other thing to consider is also there's an element of customer disruption here, because to actually enable the span capability, you may have to reconfigure or patch the system, the actual switches to be able to use span. What could be the impact there? The other thing to consider is that your staff, you need to manage these switches. You have to configure them. If you have to replace a switch, then you have to reconfigure the span ports on it. And ideally, you really need to monitor the switch after you started to use span to make sure that you're not hitting a performance issue with the switch and that it's not dropping packets. Span is a lower priority on the switch than that of the normal switch ports. And some manufacturers absolutely provide specific guidance that you do not use span for security monitoring. It's there for troubleshooting purposes, not for security, not for constant monitoring of the network. The mention around performance and that span ports can drop packets. Not only can they drop packets, but they can change the timing of packets. Also with a span port, if there are corrupt packets, they will just drop those. There will be no notification, they will just be dropped. If there are oversized packets, they will be dropped. Now, when you come to configuring span ports, if you configure on a one-to-one basis, i.e. if you want to just mirror one port's worth of traffic out of one port, then you can guarantee there will be no packets lost. But when you start configuring multiple ports of the switch to be mirrored out of one port, then there's a potential to lose packets. Now, in OT environments, the traffic utilization levels are much lower than an IT environment, but you still have to consider the sum of those ingress ports and the design of the actual switch itself, because the issue is not so much the speeds of the ports, it's actually the buffer memory within the switch. And you start hitting a congestion issue within the buffer memory of the switch. And so you can get into a situation where you do drop packets. So not only do we drop packets if they're corrupt, but there are certain types of packets that switches will automatically drop. So you cannot guarantee to see all of the data using span. And finally, a perhaps more concern to a lot of people is there are a security vulnerability. A span port is an active switch port. It has a transmit and it also has a receive feed. So potentially you've opened up a port which is addressable and traffic could be directed back into a network through the span port. So, the switch is a software product. It can be hacked. It's addressable. It can therefore be hacked. So you've opened up a potential method of actually getting into a network. So certainly a lot of the regulators are actually insisting that span is not used, or if it is used, then a data diode is used on the span port to ensure that no traffic could ever be injected back into the live network through the span port. So at Garland, we have what we call data diode span taps. And with a data diode span tap, what we do is ensure that data cannot be injected back into the switch port. So in the top example there, you see a span feed from a switch. It's connected to one of the tap ports. And we mirror out here. In this example here, we're mirroring out of two ports, out of B port to one IDS tool, and out of the C port here to a monitoring tool that the customer might have. And basically, we inhibit data being sent back through the B port or the C port through to the A port. Basically, physically, it's impossible. There is no electrical communication path between the receives on the B and C ports to the A port. The other reason why people use these span taps is it offers some additional benefits. So yes, we're here taking one span port and we can feed it to multiple tools, but we can also do media conversion so that maybe the span port's coming out in copper, but your monitoring device is located remotely. So you need a fiber link to transport the data to that monitoring tool. Well, you can do that with one of these span taps. In the bottom example here is one of our high density aggregation taps. And here we're taking span feeds from 8 switches and passing that out to an IDS system off of just a single monitoring port. And again, that IDS, there is no way back through from that IDS system back to those switches, and there is no communication path between those switches, between any of those ports of those switches. So it's a complete data diode design. So having said everything around taps and span, it's recognized that it's best practice to always use a tap to obtain mirrored copies of the traffic. You know, there's never any need to touch the switching fabric or upgrade it. You guarantee of getting 100% visibility. There's never any changes to the timing of frames. We can provide packet visibility to more than a single tool. And as already mentioned, no single tool is sufficient to secure a network completely. There are fail-safe designs. So in the event of a power fail on a tap, the network link is maintained. So there's no disruption to the network. And our network taps are unidirectional devices. So data that's monitored, mirrored out, you cannot send data back into the network. But as well as taps, there's also a need to aggregate data feeds, whether it be from taps or whether it be from span ports, because you would tap in multiple locations. You want to see the data. You don't want blind spots in the network. So in this example here on the Purdue model, you can see we're tapping at level 1, or in the Purdue model here, between the PLCs and the RTUs and the switches. And we're also tapping at level 2 between the HMIs and the switches. So here we're tapping in multiple locations on the network. We take these tap feeds back. Now, we can aggregate those in a security sensor. So if the security center can have multiple interfaces, we can send all of those feeds back to the security sensor. However, another mechanism is to use a packet broker. And with a packet broker, we aggregate all of those feeds together and then provide 1 or maybe 2 feeds to a security sensor. So there's two, as I said, there's 2 mechanisms. You can aggregate within the sensor, or you can use a packet broker. So, and there's pros and cons of each. So if you're using a sensor with multiple interfaces, basically what you're doing is adding additional interface cards into your appliance or system. And the advantages there is there's no additional device to set up. It's all within your security sensor in your IDS system, and it's relatively simple to set up. The disadvantages is that if this mirrored data is required by other security tools or other network monitoring tools, it's not going to be available. It's only being sent directly into that single sensor. And then you've got to consider also what are the costs involved, particularly in terms of licensing and your maintenance renewals when you've got lots of different tap interfaces coming into a single sensor. So the alternative approach is to use a packet broker. This is a physical device that's installed between the taps and span ports and your security sensor. The advantages here is you have the ability to share data between multiple tools. So not just a single sensor, you can also redirect a copy of the data to a monitoring device or a second IDS system. You can improve the management of both your inline and out-of-band security tools, because with certain models in our packet broker range, you can connect your firewalls and maybe your data diodes that exist in your network also to this packet broker. And then you have one management platform that's managing multiple disparate security systems. And you can improve the performance and lifespan of your security tools by using a packet broker. The disadvantage is it can sometimes be a higher additional CapEx cost. And it's another device that you need to install and manage. Well, I'll give you one example, and this is, okay, albeit a smaller ICS security deployment, but it's a very cost-effective aggregation method that we're seeing used a lot. So in this example, quite often what you see in OT environments is a ring, a fiber ring. It could be 100 meg, it could be 1 gig. In this example, we're tapping that fiber ring. So in this example, we're using 100 base FX fiber taps to tap the traffic on the ring. And then we take the feeds back from those taps. And rather than use a packet broker, we're using an aggregate, a high density aggregation device called the INT1G10 CSA SP. So this is the device that we can use for take span feeds from lots of span ports. So in this example, rather than taking span ports, we're just taking the mirror ports off of our switches, bringing them back to this device, and then we can feed out of this device. It has 2 monitoring ports. So in this example, we're feeding an IDS security platform and a network monitoring platform. But, it doesn't have to be, we didn't have to use taps in this diagram. We could be using the span ports on those switches on the ring. So we could also take the feeds from those span ports on the switches and again, bring it back to this INT1G10 CSA SP. And this product is a very cost-effective mechanism to aggregate a lot of feeds. And you can actually daisy chain 2 of these tools together, 2 of these devices together. So you actually give you 16 feeds back to your IDS and your monitoring tool. And that really completes my presentation today. It was really just an insight into some of the challenges that you face in OT environments and the sort of devices and ways around it that we actually use in Garland technology to provide network visibility to security devices. Some takeaways you can find here for some of our white paper documents and various guides in terms of designing OT networks. Thank you very much. And now my voice just about is finished.
Okay. Thank you, Ross. Thank you. Thanks a lot for the presentation and that you made it through. So even if you're very thick, unfortunately for you, there are a couple of questions to answer. So, but at the moment there are only 3. The first one is a very easy one. It says, what's the difference between a diode tap and a data diode?
Wow. So our data diode, there are instances where you can use a data diode tap as a pure data diode. So that's the first thing I want to make clear. Out of a data diode tap, if it's a tap, then the data diode functionality is between the monitoring ports back to the tap, so the live network. So you connect a live network and then you cannot inject traffic back from the monitored ports on the data diode into that live network. With a data diode span tap, it's slightly different because here you could actually use that in a data diode implementation. What a data diode, but it is a hardware data diode. So there is absolutely no communication path. We do not spoof any protocol handshakes. So if you're trying to use it as a pure data diode between 2 devices, if the network between those devices requires some sort of handshake, then it will not work because it physically will not allow you to pass data back. So generally it will only work in a UDP environment where there is no handshaking. But then you have to be concerned about what the application is doing and whether the application needs handshaking. So it really depends on the application as to whether you can use a data diode span tap as a pure data diode. But it is a different device. And the other answer is it's a lot more cost effective than a data diode tap, or a data diode span tap is a huge amount more cost effective than a data diode device.
Okay, yeah, that's how we know that a data diode or a diode tap is much cheaper than a data diode. The next question is, what happens if the tap has a failure? Is there some way of building up redundancy, or if the tap is broken?
So the only way to do redundancy on a tap, if it's a tap, is to put two taps in serial. So then if one tap failed, then it would go into fail-safe mode, so it could keep the network link up, and the second tap would do the monitoring. So you can do it, but then you'd have to bring both feeds back. So accept that you're going to get two feeds of duplicate traffic. To be honest, people do not do it because it's monitored traffic, so they do not see it as mission critical.
Okay. Now, the last question is that, the OT networks are in rough environment. So you need a special specification for temperature, humidity, dust. So what can you do it with Garland taps, or?
Yes, and the short answer is yes. We have extreme environment taps, so taps that are all of our taps are metal cased. They don't have any fans in the taps, so dust is not really a concern. You can mount our taps in 19-inch rack mount, or in DIN rails, or you can just gaffer tape them to a side of a cabinet if you so desire. We've got them tie wrapped inside various test vehicles. So they are, and we'll have things like fixed lock connectors on the power receptacles, DC power options, and we have taps that have been seismic tested for use in nuclear power plants, that also have been heat tested as well, again for use to meet the stringent requirements for nuclear power plants. So yes, we do have a range of products with different extreme environment tests and certifications.
Okay, great. So at the moment, I have only the one question which I can answer. If the slides are available, and yes, they are. So if someone needs to find slides, and we send it out anyway. So and if you have further questions, just send us an email, and then we are going to answer it, or give us a call or whatever. So since there are no other questions, I would say thank you very much for everybody for joining our webinar, and I wish everybody a nice and sunny afternoon. Thank you, Ross.
And I'll return to my sick bed now. Thank you, everybody.
So, thank you very much. Vielen herzlichen Dank für die Teilnahme und einen schönen Nachmittag. Tschüss.